Okay, Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Thank you everyone. Yesterday cikgu macam actually tak seberapa okey sangat lah macam nak migraine. Okay, hari ni kita sambung very quickly. 1 hour I think is not enough actually untuk cover general physics sebab general physics is very quite a large topic ya. Okay. So anyway, kita baca doa bismillahirrahmanirrahim. Ta'ala na ikmataka wa sya'lana min khazaini rahmatika ya arhamar rahimin. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Okay, kita tengok soalan ni. Okay, so yesterday kita dah tengok a few questions about motion and kita dah tengok recap topik motion. Saya receive questions juga after class tapi itulah tak sempat nak respond. Cikgu reply. Okay. Tengok soalan number 7, we have done this one, betul tak? How far the transfer? Okay, number 7, have we done this? Kita stop dekat number 6.
Nombor 6 tapi nombor 7 belum.
Nombor 7 dah cuba. Ada yang dah siap ke? Kalau nak mengikut macam ni nak siap kan sebab saya tak bagi kan. So hari ni saya ingat saya nak share the answers tapi itulah tak ada group kan. Nak bagi dekat chat ni mungkin ada yang dapat download, ada yang tak dapat download. Okay. So number 7, how do you do this? Okay, maybe you boleh tengoklah cara kerja and the best thing kalau you boleh salin juga sambil-sambil tu nak ambil recording pun boleh tapi later lah, that will be very later lah. A car travels at an average speed. How far the car travels? So kita just use formula. Okay, average speed, you know the formula. 16 kilometer per hour. Okay, and then for the time 15 minutes. How does the car travel in this time? Okay, now the answer given is in unit kilometers. Right, so kat sini kita tak payah nak ubah. Right, and then kita tahu the formula for distance ataupun average speed. Saya buat simbol. Berapa? Apa dia? Total. Remember yesterday? Total distance over total time. So substitute. We do if sound. If sound ni adalah tips. I for information, F for the formula. So we have written the formula as substitute. So kita substitute the values. 60 kilometer per hour. I will do that. Sebab hour tu kita nak ubah. Okay, I will write hour tu 1 hour lah. Sebab 60 over 1 is 60. But I just write 1 kat situ. Total distance. This is what we want to know as time 15 minutes. So we change that into hour. How to change that into hour? So that is it times? Divide Betul. Dia macam day per hour, per minute, per second. Ini kita times 60 times 60 times 60 ni bukan 60 ni. Day ni kita times 24 hour. Betul. Tapi kalau nak daripada second ke minute, minute to hour, hour to day, kita divide. And divide 60, divide 60 ni divide 24. So kat sini kita bagi 60 lah. Correct. Am I doing the right thing? So carilah dulu. Okay. So cari S. Buat balik calculator pula. Jadi S equals to 60 kilometer times. Okay, kita ambil yang ni. Berapa? 0.25 kan? 0.25 hour. Okay, and then we have 1 hour dekat sini. So, kita cancel out. So, times dengan 60 kilo. So, that gives us 15 kilometers. So, this is the way I write. Jadi, kalau dalam exam, you boleh buat laju-laju, buat sepah-sepah, tak apa. Tapi, kalau dalam paper tu, you tengok, this is the process of understanding the question and then doing it step by step. A for answer, U for unit. Ni tips untuk answer calculation question. Okay, number 8. A ball is dropped from a tabletop. Okay. Air resistance may be ignored. Which row describes the velocity and the acceleration of the ball at point X? So remember, this one, object is falling freely. Yeah. Semalam kita dah belajar tentang free fall. And you know, free fall means an object is falling due to gravitational force only. And we know that as long as we are in the earth, there will always be a gravitational force toward the center of the earth. So anything above the earth, it falls. Semuanya ada acceleration. Okay. So acceleration dia, what's the value? As IGCSE students kena tahulah. Yeah, all the objects are accelerating and the acceleration value is G. And how much is G? 9, sorry. IGCSE kita ambil 10 meter per second square. So, which row describe? So, that shows if you understand this one ni, saya repeat ya, apa yang kita belajar semalam. If you have understood that one, kita tahu the answer must be or A or B only. Okay. So, A or B. Then velocity. Kita dah belajar juga daripada relationship. Okay. So, ST. And then daripada graph ST, kita dapat graph apa? VT. And then daripada VT, kita boleh dapat graph acceleration time. Remember yesterday? So, from kalau graph, if we have displacement graph, we can get the velocity graph. If we have velocity graph, kita dapat acceleration daripada gradient. Now, daripada acceleration, now we know the acceleration is constant. Jadi when acceleration is constant, how is the velocity? So kita tahu velocity dia mesti begini. So that we can dapat gradient yang constant. So the answer is, kalau if you look at this, velocity is increasing. So B is the answer. Boleh? Any question? Right. Number 9, the diagram shows the speed time graph for a car, which area represent the distance travelled while the car is accelerating. Ya, kalau nak buat, okay, kita tahu semalam, okay, graph daripada we have speed graph. Daripada speed graph, macam mana nak dapatkan dia punya respective displacement? So kita dapat macam mana? Kita gunakan area under the graph. So for this graph, the graph is this whole thing. And the area is all of this. However, dalam exam, you jangan cepat sangat nak pilih jawapan. You fahamkan dulu. So the questions here says that area while the car is accelerating. So accelerating dekat mana? Only the X. So the answer is A. Kalau tak ada siapa yang stopkan saya teruskan saja. If you have question, you can just cakap sesuatu. Sebab kalau awak tulis dekat chat, I cannot read it. Saya punya laptop ni habis bateri pula. Saya guna iPad lagi. Please kalau ada siapa nampak kawan-kawan tulis apa-apa pun, tolong siapa yang ada mikrofon yang boleh bercakap, tolong cikgu ada soalan, bacakan. Boleh? Right. Two distance time graphs and two speed time graphs are shown. Which graph represent an object that is at rest? This is also another easy question. Okay. Which graph represent an object that is at rest? So object is at rest can be shown by, if you remember, yesterday kita bincang kan. Only can only be represented by the graph of distance selalunya. Kalau speed ni susah nak tunjuk unless dia punya graph betul-betul touch zero. Sebab zero, bila speed tu graph dia dekat zero, itu memang betul lah zero speed. Zero speed maksudnya not moving. Tapi kat sini neither of them kan. Bukan. So the answer definitely not C and D. So number 10 dapat apa jawapan dia? Can you guess?
B.
Yes, B is the answer. Yeah. Okay. A geologist. Okay. A geologist compares the volumes of three rocks. Three measuring cylinders contain different volumes of water. He places each rock into one of the measuring cylinders. The diagram shows the measuring cylinders before and after the rocks are put in. Which row shows the volumes of X, Y, and Z in order from largest to smallest? Very easy question. Soalan ni tak payah nak berfikir sangat. So the answer is B. Setuju? Sudah habis. Sekejap. Okay, the answer is B. Yeah. Volume kan? X, B, Y, the largest volume. Cuma kat sini perangkapnya selalu student, okay, ni memang senang soalan. Tapi dia tak baca betul-betul. Soalan nak largest to smallest. Largest would be the Y kan? Okay. Y and then X and then finally Z. Okay. I think we have discussed question number 12. Okay, number 13 is very easy. What does the area under the speed time graph represent? That's the distance travel. Number 13, D. Number 14, a car travels 100 km. The journey takes 2 hours. The highest speed of the car is 80 km per hour and the lowest speed is 40 km per hour. What is the average speed of the journey? So how do you do this? You ignore all the other sentences tu. The highest speed of the car, the lowest speed, tu tak perlu. Yeah. So number 14 ni you just use 100 km divided by 2 hours. So 100 divided by 2, B. B is the answer. Boleh? Faham yang saya cakap? Sebab number 14 ni you tengok soalan. Soalan nak average speed. Jadi the average speed, kita tahu formula average speed. What is it? Total distance over total time taken. Yes. Sebenarnya soalan dekat sini je. A car travel 100 km, so that's the total distance. The journey takes 2 hours, that's the total time. So the rest of this tak payah. Tak ada apa-apa. Dia just nak panjangkan soalan. Ataupun perangkap saja. Nothing to do to calculate that one. Okay. So the answer is B. Brilliant. Number 14. Okay. Alright. Yang ni pun nampak. So dia ulang-ulang soalan yang lebih kurang sama je. The speed time graph shows the motion of a car. Which row describes the motion? PQ. Very quickly. You boleh jawab sendiri dekat rumah tu. Very quickly. PQ. So what is it? So this is a graph of what? Speed time. So PQ accelerating. Okay. So the answer A or B?
A.
A. Okay. Between QR moving at constant speed. Number 16. Sorry ya, saya tak tulis apa-apa kejap. Saya charge pen sekejap. The diagram shows the distance time graph of an object. Which statement describe the object? The object is, okay, and then this one, you tengok dulu sebelum answer. Yes, you tengok dulu the distance. This is a graph of distance against time. So the answer is?
B.
Yes, it is moving at a constant speed. All right. A tennis player hits a ball hard and 0.4 seconds later hears the echo from a wall. The speed of sound in air is 330 meters per second. Okay, how far away is the player from the ball? So that's easy. You know the velocity, you know the time, you want to know the distance. So you just use formula of V against, V pula. V equals to S over T and 330 meter per second equals to the distance and time 0.4 second. Okay, kalau you buat macam ni je, 330 times 0.4, dapat tak jawapan?
Tak.
Tak dapat. Kenapa?
Distance 2 kali.
Yes, very good. Because this is reflection of waves. Ada echo. So, distance 2 times. So, dia pergi, patah balik. This whole thing took 0.4 second. So, you kena buat 330 times, sorry. Bukan 330. Okay, 17A. Okay, I think that's enough. So, yang lain-lain tu lebih kurang sama. Ini semua kita dah buat. Okay, ini pun basic. Okay, you have understood this one. I think we have done that one similar. Alright. Okay, yang lain-lain ni sama sajalah. Alright. Okay, tak ada. Okay, we move on. Ada yang ni pun lebih kurang sama je. What is the acceleration of the car when time is 40? So, macam nak jawab ni, ada dua cara lah. You calculate the gradient here. Choose any 2 points. And then dah tengok average dia macam mana. Ataupun you kira apa tu? Berapa? So number 42. The answer is 42 When time is 40 second. So dia nak tu 40 second betul-betul. Dekat betul-betul 40 second. So where is it? This one. So this is actually dekat mana ni? Peak dia. Okay, kalau dekat peak sini ada gradient tak?
Tak ada.
Student? Tak ada. So what do you think the acceleration at exactly 40 second?
0.
Yep, the answer is 0 meter per second squared. Okay, itu saja. Okay, kita move on. Next question. Kita tengok contoh soalan. Length and time. Question like multiple motion. So saya rasa ini semalam kita dah buat belum? Kita tengok contoh sikit lah. A bus travel. Okay, you all baca dulu soalan ni. A bus travels at a constant speed. It stops. It stops for a short time and then travels at a higher constant speed. Using the axis in figure 1.1, draw a distance time graph for this bus journey. Okay, so macam mana nak sketch ni? At a constant speed. So how do you show it? Ya, kan? Dia naik macam ni. Okay, and then dia mesti positive gradient. You stop dalam mana-mana sebab dia tak bagi any value. So kita just sketch and then it stops. How do you draw that?
Straight
Ni
line.
graph distance. Yeah, straight line. Okay, next. And then travels at higher constant speed. Macam tadi juga, tapi higher constant speed. So, make sure you punya line, okay, the line will be steeper from this. Kalau ini, this is the steepness kan. Yang this one kena steeper. Jadi kalau ini tersambung, that would be the slope. Jadi yang ni tak boleh macam ni juga. Nampak macam sama slope dia. So you kena buat steeper. Steeper would be something like that. Nak menunjukkan dia ada higher velocity. Kalau kita cari gradient, so this is the gradient, and this one is the gradient. This steeper slope. Ataupun kalau you dah baca soal daripada awal, you boleh buat lah. Ni, okay, straight. Then, so that is more obvious. Alright. B. Figure 1.2 is the speed time graph for the motion of the lift to the top of floor of the building. So ini, motion of lift. So kita ada lift. Lift ni moving up. Moving up. Right. Use the graph to determine the distance from the ground floor to the top floor of the building. So how do you do this? 4 marks. So first you have to write
Area under the graph.
Yes. Very good. So apa tu? Distance equals to, you write this one first. Mesti tulis ke cikgu? Wajib. Sebab ini adalah menunjukkan you faham dan ini ada markah. Ya, ada markah. Okay, next. Kita buatlah. Jadi dia agak susah. Bukanlah susah. Dia tak susah lah. Awak kira je lah. 1/2. Ambil ni. So that is, kalau saya, I will write this. Sebab ini adalah structure question. Structure question ni maksudnya soalan dekat atas, jawapan dekat bawah. Jadi, saya boleh buat macam ni. Area A plus area B plus area C. And then I will do one by one lah. A 1/2. Ini nampak you sebenarnya masa exam, you tengah communicate dengan your examiner. Jadi yang ni adalah showing what you are doing. Jadi senanglah examiner nak bagi markah. 1/2 times apa ni? 3.123, betul? Times 3.3 times 5 point. Apa tu? 6, 7, 8, 9, 10. Tu berapa tu? 6.5, 6.5. So that's A. And then B, 6.5. Sini 20. So 20 minus 6.5, berapa? Hello? Saya ni online lagi tak ni? Okay, so that's B. And then half times. You can tengok betul-betul lah 3.3 times berapa ni? 25 tolak 20. So that's easy. 5. Kirakan berapa? Dapatlah jawapan 62. Unit jangan tinggal. So 62 meter. So you jawapan sekali dengan unit. Okay Boleh. So yang penting saya nak tunjuk ni So dia kadang-kadang dia tahu tapi dia buat sambil level. Bukan tak? Dia buat sikit. Dia buat kat sini. Conteng sana, conteng sini. Tengok ni. Ni proses. 1, 2 markah. 3 markah. 4 markah. Dengan correct unit. Okey. Yang lain-lain saya rasa sama sahaja. Cuba dia kata kat sini lah. State how the graph shows that the deceleration of the car has the same numerical value as its acceleration. Ini soalan dia. This question asks you, the graph shows how the speed of the car changes as the car passes through a small town. Okay, calculate the distance. Okay, we know how to calculate the distance. Sama saja macam tadi. 2A tu speed. Okay, ataupun kita nak cari area under the graph lah. Okay. And dia guna kertas graph macam ni. So you make sure you tengok, you baca reading betul-betul. Nah, dalam exam paper besar. So you boleh nampak. Jangan tersilap. Itu one of the reasons kenapa dia guna graph paper. Okay, so this one, area under the graph. Settle. B, calculate the acceleration of the car between C and D. C and D mana? So, nak acceleration, how do you do? You find the
Gradient.
gradient. So, this one, you calculate the gradient. That is an easy task. Tapi ada unit tak the gradient? Gradient CD. Ya, you tulis macam ni. Dia banyak dia soalan dia. So, D is at 30, berapa tu? 31, kan? So, 31 tu ada unit tak? Okay, 31 and then C tu berapa? 14, that's 13 lah. C 13. Okay, 31 and 13 ni ada unit tak?
Ada.
Ada. What's the unit? Meter per second. Jadi you must write the units when calculating gradient. Okay, and then the time at the respective point tu, D, mana tadi? D. So, you nak buat line tu, you buat je. You tunjuk anak panah supaya mata tu tak tersilap tengok. 51, 52, 53, 54 and C 42. 54 minus berapa tadi? 54 minus
42.
42. Okay, and then that one also ada unit, so second. Jadi, tak kisahlah jawapan dia apa. Ni soalan nombor okay, jawapan dia katalah 1.5. Ada unit tak tu? Meter per second. 2 kali kan per second kan? Right. So your answer mesti include unit. Tak ada unit salah. 1, 2, sorry. You can answer tell the gradient. Satu markah. Markah nombor 2, you substitute correctly. Markah ketiga, answer plus unit. Okay, itu saya nak point out. Kadang-kadang student dia conclude, cikgu, gradient mana ada unit? Tak ada, salah. Physics lain kalau dalam mathematics, memanglah gradient tu tak ada unit lah. Sebab kita belajar gradient. Sekarang ni kita apply mathematics into physics. Okay, and then C ni, state how the graph shows that the deceleration of the car has the same numerical value as its acceleration. Okay, so kalau dekat sini tak ada graph, okay kat sini dia tak ada refer kepada mana-mana bahagian. Cuma dia kata, the question ask about numerical value. Numerical value ni maksudnya the magnitude. The magnitude ke, the value lah, the value. So it's easy lah. Acceleration sebenarnya, deceleration tu adalah acceleration juga. Kalau acceleration negative value, so ini adalah deceleration. Yang berubah hanyalah satu ada negatif, satu lagi acceleration yang positif tu dia positif. Ini adalah acceleration. Jadi di sini if this one negative 20, acceleration pula 20. Okay. So, macam mana kita tunjuk the graph? They have the same value. So, the answer is very simple. What is the answer? It's the gradient. Apa dia? Line of same gradient or slope. Faham tak? It's just that. Apa dia? Negatif kan? Negatif. Tak payah cakap negatif tu. As long as cakap same gradient. Maksudnya, cuma kalau acceleration tadi, gradient dia like this. And deceleration You ambil juga ni. Seolah-olah saya buat macam ni supaya you nampak apa yang cikgu buat. Yang sama, cuma kan? Jadi kita jadikan dia negatif. Macam tu. Okay, itu maksud dia. Alright. So saya rasa yang that's it for a motion. Okay, selepas motion apa yang kita belajar? Okay, mass and weight. So semalam pun kita dah sentuh tentang mass and weight. Okay, you kena tahu untuk IGCSE, mass and weight ni also can be asked, boleh ditanya juga. Cuma cikgu lihat. Question paper. Okay. So state what is meant by center of mass. Center of mass of a body. Dia boleh tanya. Satu markah. Jadi kalau tengok semalam, center of weight ni ya kat sini. Kalau objek regular senang. Ya, regular object dia mesti dekat center macam ni. Semua orang okey Okey. Ni pun sama. Okay, tapi kalau ni pun regular. Now, what about irregular object? So, irregular object untuk exam ataupun untuk syllabus IGCSE, you kena tahu how to find the center of mass. Ada activity dia. So, this is the activity. So, first, you place the irregular object like this, kan? Dekat satu paku kat sini. And then ada tali. Ada tali kita letak kat situ. Ada plumb line. That is what we call as plumb line. Lepas tu kita letak pemberat lah. Berat kat situ. And then what we do, kita tukarkan pula. Tadi kita masukkan dekat lubang yang ni. Jadi kita tandalah the line. Ambil pensel, kita tanda the line. Okay, next, kita bukakan dia. Kita masukkan dekat lubang yang kedua pula. Macam ni. So tadi, this line, kita dah draw. Kita dah draw line yang ni. So next, when this is the position of the irregular object tu, so this is the plumb line. And then you draw another line. Jadi you do the third time, okay? Tadi the first one, second, and then the third time you tu ubah lagi. So you dapat yang the third line. So let's say ni first line, second line, and then the third line. So dekat titik pertemuan tu, actually that is the center of the mass. Okay. Now, by the way, what is center of mass? So, center of mass of a body is defined as a point. Nampak tak? Ini. This is a point. Yeah, this is a point. Point of what? Where all the mass of the body, entire mass of the body appears to be concentrated. Right? So, let's go back to the question. So, you write that. Tulis. A point. Dekat mana? In a body. Okay, kenapa dengan point tu? Where all the mass, the entire mass appears to act. Okay. Boleh? B. Okay, ini energy. Nanti kita sambung kejap lagi next time. Kejap lagi. Okay, saya nak tunjuk pula soalan mana ni. Okay ni, an example question. An astronaut, baca sama-sama lah because you don't have the paper. Kalau awak tengok pun boleh. An astronaut has a mass of 65 kg on Earth where the gravitational field strength is 10 Newton per kg. Okay, calculate the astronaut's weight on Earth. So you kena tahu this term maksud dia apa. Okay. Now, calculate the astronaut weight. So, what's the formula? W equals to?
mg.
mg.
Alamak. mg, so mass dia 65 kg. Kg tu berapa? So, this is the G. Yeah? 10 Newton per kg. Okay. Ya, yeah. Apa yang cikgu buat ni adalah what is expected from you. Saya expected the same thing. Examiner pun expect the same thing. Apa dia? Now, you write this. Ya. Yeah? Nah, ini ada student dia akan ingat lah kat belakang nak tulis unit. Ada student dia laju je nak buat cepat siap. Tapi sebenarnya nanti markah banyak hilang. So, kg dengan kg cancel out. So, dapatlah unit. So, finally, you will not forget to write the unit. Cikgu tahu, semua orang tahu unit dia. Ya, tapi yang sekarang ni kita nak pastikan you ingat. Itu je. Nah, complete the following sentence. The astronaut's weight on Earth is the... What is that? What is the definition of weight? Is the... What? Gravity... What force? What is the name of force?
Gravitational.
Yeah, gravitational force. Very easy question. Between astronauts and the Earth. Okay, the astronaut undertakes a moon landing. On the moon, the gravitational field strength is 1.6 kg. State the astronaut's mass on the moon. Cepat jawab.
65.
Yeah, okay, 65 kg. Unit jangan tinggal. Okay, calculate the weight of the astronaut on the moon. So, itu masih lagi samalah. mg. So, 65 kg times, what's the g?
1.6.
1.6 Newton per kg. Kan dapat berapa? Lebih kurang
204.
104 Newton. Okay, alright. Itu sahaja, senang je. Okay, and then dalam topik ini juga, bila kita tahu mass of the center of mass of an object, differences between mass and weight, okay, you need to know also about stability. Yeah? To suggest which car has the greatest stability, so mestilah racing car. Why? So the reason is, it is wider. And then what else? Dalam topik center of mass. What do you think about the center of mass? Rendah kan? Kalau dekat sini, this is a taller car. Ini shorter car. So, mestilah center of mass dia somewhere high. Kat sini somewhere lah, dekat mana-mana, kat bawah lah. Yeah? So, when the center of mass is lowered, jadi dia more stable. Kalau center of mass tu high, that's why lah macam lori, bus, semua senang terbalik kan? Sebab the center of gravity, center of mass tu higher. So less stability ataupun it's easily topple kan. So jadi kat sini kita kata lower center of mass. Nampak ni memang senang, tapi kadang-kadang kita lost, tak dapat jawab. Lupa kan. Okay, sebab tak baca, kita baca yang susah-susah saja. The cars have the same weight. Study figure 5.1 and suggest why the stationary racing car exerts less pressure on the ground. Okay, ini topik pressure. Anybody knows the answer walaupun tak belajar lagi? So remember, pressure equals to force over area. So when the soalan tanya, mass of these two are the same. Jadi when they are not moving, dua-dua tak bergerak tengah parking, dia kata apa tadi? Racing car exerts less pressure. Yeah. Pressure is this one lower. Pressure ni higher. Kenapa? How does that related to force over area?
Tayar racing car besar.
Yes. So the answer must be larger area of contact. So dia kata the tires kan, larger tires. Ataupun sebenarnya kita kata ada wider area of contact between tire and the ground. Okay. So ini boleh guna formula ni untuk jawab. The family car's tire each have 0.012 in contact with the ground. The weight of the car and its contents is 9,600. Calculate the pressure. So first you kena buat apa? Wajib tulis ni if so. You dah tahu info, ni adalah area, ni adalah force. F apa F? Formula. So you write down the formula. Okay, lepas write down formula, S tu apa? Substitute. So 9 Newton. A, what's the area?
.012 times 4.
Yes, sebab of the car, by the car. So 0.012 times 4 meters squared. So dapatlah around berapa? Berapa ya dapat? Ada yang tolong kira?
200,000.
200,000. Ada unit tak?
Ada Pascal.
Apa? Okay, Pascal ataupun Newton per meter squared. Okay? So itu je. State what is meant by term. So you can tahulah what is meant by weight. So weight is the force of gravity on a mass. Okay, what is density? Density is mass per unit volume. So you can write this one ataupun you tulis macam ni lah. Mass per unit volume. But make sure you write in full. Mass volume. Okay. Ni jadi soalan. Describe how the student could find the mass of an irregular solid object. So boleh tengok macam tadi lah. And then describe how the student could go on to find the density. So you dah tahu mass, you nak tahu density, you kena cari volume pula. Remember how do you find that volume? For irregular object, macam mana? Guna
Water displacement method.
Water displacement method. So you cerita balik, guna water displacement method and then find the difference in water, so dapat 2 markah. Jadi bendanya senang saja. Cuma macam mana nak jawab. Okay, so that's it for mass and weight. Lepas tu, kita tengok forces pula kan. So sebenarnya kalau tengok nota ada banyak. Jadi kalau terlalu banyak ni tak sempat. Jadi kita tengok, you boleh, sebenarnya you dah belajar dah. Kan? Tapi kita you boleh tengok balik lah. You dah belajar, so nanti boleh study balik. Sekarang ni kita buat revision untuk tengok a few questions. Jadi kita relatekan dengan mana topiknya. So 1.5 force. So force ada banyak. So force, what is it? Force is a pull or a push. So when there is a force, what is the effect that you can see? Object start to move, object stops, object speeding, the change direction and so on. And you need Newton, and force is a vector quantity because it has magnitude and direction. And usually in order to measure force, kita use spring balance. Okay, and then you kena tahu all three Newton's law. Nanti masuk SPM ada lagi Newton yang lain. Sekarang okay, Newton's law ada 3. So first law is talking about balanced forces. Right, and then kita second law, unbalanced forces. Apa dia? Okay. Object tu mesti be accelerating or decelerating. So maksudnya kat sini daripada second law kita dapat equation, force directly proportional to acceleration. Daripada situ, from relationship directly proportional, nak tukarkan kepada equation, kita tambah a constant. So that constant tu adalah the mass. Okay, right. So this is second law. And third law, when there is an action, there is an equal reaction towards an object. So kalau ada buku, the book is on the table. So book mesti ada mass kan? And mass ada weight. So there is an equal but opposite force, normal force ke atas yang hold the book so that the book is not moving downward, ataupun weight ni weight ni dia stablekan oleh the normal, jadi buku tu tak naik ke atas. Macam tu lah. Occurs in pairs. Okay. So this one Newton's first law. A body at rest remain at rest. A body in motion remains in motion. And then kena masukkan yang ni, unless an unbalanced force acts on it. So ini sebenarnya adalah kalau inertia tu, inertia is Newton's first law. Okay. And Newton's second law, this one. This one is that I have just mentioned. Buat F equals to MA. Dapat daripada eksperimen. So daripada eksperimen tu, dia tunjukkan F directly proportional to A. Okay, Newton's third law, tunjuk kat sini. Tengok the book ni. So there is a force here by the engine of the boat. Direction of motion of boat is this way. So engine punya force this way. But at the same time ada current kan, ataupun ada resistive force by the water tu, yang resistance, and ada drag, air resistance. Jadi you kena tambah lah ni dengan ni. Okay, tu one example. Okay, yang ni pun ada example macam tu. Okay, kita tengok contoh soalan. Oh ya, another one dalam topik centripetal force. Pun dalam topik force, ni akan tahu. So when object is moving in a circular motion like this, there is a centripetal force. And centripetal force always pointing to the center of circle kan. To the center. Okay. Kenapa macam tu? Because velocity keeps changing. Although the speed is constant. Speed constant. But velocity is changing. Alright. Tengok soalan. Contoh soalan. Motion. That should be force. Force ada banyak Kita tengok forces. Okay. State the factors which completely describe a vector quantity. Vector quantity apa?
Magnitude, direction.
Yes, itu je jawapan yang dia nak lah. Right. Dia ada magnitude and direction. An aeroplane is flying towards the east. So kalau saya buatlah free body diagram. Towards the east is mana? This way. In still air at 92 meter per second. A wind starts to blow at 24 meter per second towards the north. Macam mana tu? Ni. 24 meter per second. Draw a vector diagram to find the resultant velocity of the aeroplane. Use a scale of 1 equal to 10 meter per second. Okay. Soalan ni, dia nak resultant force. Okay. Tapi, Kalau ini dalam paper 1, you boleh simply find, okay, kita tengoklah sini 92 and then 24 meter per second here. Jadi the resultant tu is this one. Dan ini you nampak apa? East and north adalah 90 degree to each other kan? So kita boleh guna theorem Pythagoras. 24 hypotenuse to resultant velocity equals to 24 squared plus 92 squared, then find the square root. Itu kalau soalan tak minta spesifik macam ni. Sekarang ni soalan ni dia nak minta guna apa? Cara drawing method. So you kena tahu dalam physics IGCSE ke SPM ke sama je. Kita ada drawing method, vector diagram. So macam mana nak buat ni? So first, skill dah diberi. Kalau skill tak diberi, you kena buat sendiri. You tetapkan sendirilah berapa skill yang you nak guna. Sekejap saya nak ni. Kita nak guna pembaris. Mana? Anak saya contoh yang tak ada pun. Alah. Mana dia simpan? Oh, sudah. Salah Kita buat je lah baru. Paste. Ini paste ni. Sorry. Ni jap. Copy. Kita tengok betul-betul. Ada pen kertas tak you all? Buat sekali supaya you tahu. Sebab kalau you tengok je, dia macam menonton lah. Kalau menarik kita akan ingat lah. Kalau tak ingat. Sebenarnya saya nak ni je, nak soalan. Ya Rabbi. Inilah kan soalan dia. Okay. Dan. Okay. Okay, draw a vector diagram to find the resultant velocity of the aeroplane. Kenapa tak boleh kecilkan ni? Tak apa. Okay, so kita nak draw. Okay, you choose first. Okay, mana-mana lah you nak start dengan 92 ke 24? So, 92. 92 berapa kalau 10 meter? Jadi 9.2. Kita keluarkan pembaris 9.2. So, kalau you start dengan sini, Alah. You ni saya buang je lah ni. Tak ertinya guna ni. $9.2. Buat je lah. 1, 2, 3, 4. 1, 2, 3. 4, 5, 6. 7, 8, 9. 1, 2. Jangan terlebih terkeluar. Nanti akan jadi salah jawapan awak kan. Betul. Okay. So that's 9.2. 92. Kita tulislah, labelkan dia sebagai 92 meter per second. Then awak buat pula dekat sini. Okay, kenapa dekat sini? Boleh tak kat tempat lain? Berapa dia beli? Yang north tadi berapa? 24 So kalau 24 berapa cm?
2.4.
2.4. Okay. Apa yang saya buat ni, you kena make sure kalau arrow ni kita ada ini kepala head ni tail. Untuk dapatkan resultant force, you kena arrange, katalah ini yang ni ada x meter per second. Dan kita ada y meter per second. And then kita nak cari the resultant force. Dua-dua ni act on a body. Dua-dua ni act on a body. Katalah ni bergerak ni kat sini. Yang ni Macam ni. Okay. So dia kata find the resultant force. So kita ada two forces ni. Jadi sebenarnya you ambil daya-daya ni and then arrange bukan daya lah. Ambil dia punya magnitude ni ataupun the vector ni. Arrangekan dia head to tail. So yang ni, is this correct? Is it head to tail? Tak kan? Ni head dengan head. Betul? Ini head. Ini tail. Ini head, ini tail. So kalau yang ini kat sini, head dengan head bertemu kan? Salah. So you kena untuk cari kat mana. Letak sini boleh? Head tail boleh. Sini boleh tak? Tak boleh. Ni tail dengan tail. Jadi yang the best, sinilah. Ataupun you nak gerakkan, yang ni tak bergerak. You nak gerakkan this one. Boleh. Letaklah kat mana? Sini. Tak boleh. Sini? Boleh. Jadi mana resultant dia? The resultant is this one. Tail to head of another forces. Saya masih online? Okay. So kat sini, ya. Saya masih online kan? Use your ruler. Gariskan. Hello?
Ya, teacher.
Yeah.
Yes, teacher.
Okay, ingatkan saya dah terkeluar. Mana tadi? So, where is my ruler? Okay, letak pensel elok, pembaris elok. You all kalau guna pembaris lagi senang lah. Yang ni sebab virtual kan, saya pun tak pasti benda ni betul ke tak. Tapi cara dia macam tu. And then macam, what is the value? Macam dapatkan value dia? Anyone? No? Direction dia. Yes, directionnya this, that way. So the value you kena kira lah, ukur, measure. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pun berapa tu? 1, 2, 3, 4, 5. 9 point, lebih kurang 9.5 lah. 9.5 cm. Tapi tu cm. So 9.5 cm. Maksudnya, sebab tadi kita ada scale kan? Jadi 90.
95.
It's about 95. Unit dia meter per second. Okay. Alright. So jawapan dia macam ni. Dapat 2 markah. Okay, dah pukul 9. Tak sempat nak habis banyak. Okay. So mungkin awak akan sambung dengan next teacher. So resultant speed tadi about 90, 95 meter per second. Unit mesti ada. Angle between resultant and easterly direction. Nampak tak dia cakap macam mana tu? Angle between, dia nak result ni, angle. Dia nak resultant tu sini. The angle tu to the east. East yang mana? East yang bawah. Jadi, the angle ni. Dia nak angle yang ni. Bukan A, bukan B. So, angle dia berapa? Macam nak dapatkan angle? How do you get the angle dalam exam? Macam nak dapat angle dalam exam?
Protector.
Guna protector. Awak dapat 15 degree. Lebih kurang lah. Lain student mungkin slightly different lah dia answer. So 15 tu ada unit tak? Ada. Degree. So ini dia sebab dia bagi tahu from east to east. Tapi kalau tak bagi tahu, awak kena bagi tahu 15 degree from the horizontal ataupun from the east. Jadi kesimpulannya dalam exam IGCSE pun mesti bawa protector. You might need it kan. Okay. So tak sempat kita nak pergi tentang ni moment of force. So next time boleh kita sambung. Right? InsyaAllah. I think that's all. Ada soalan nak tanya?
Teacher,
Ya?
kalau teacher tolong share notes dalam group boleh tak?
Boleh. Tapi saya tak ada, parents tak masukkan kami dalam group. Jadi saya akan bagi pada wakil parents ataupun one of you, sebab one of you adalah my student I think. Kan nanti saya share. Nanti boleh share kat dalam group tu. Alright?
Okay teacher, thank you.
Okay, bye. Alright. So itu saja. Ini sebenarnya senang je. Principle of moments. Tapi nanti sambung kemudian. Okay, bye. Assalamualaikum. Jumpa lagi.
Salam lagi teacher.
Okay.
Thank you, teacher.
Okay, most welcome.